Dear friends, in this video, we shall learn pipe and cistern. We shall try to solve the problems based on pipe and cistern asked in various competitive exams. First of all, we shall see some tips for the problems based on pipe and cistern. First tip is, if the tank fills in n hours, then in 1 hour, 1 by n part of the tank will be filled. Keep in mind, एका तासात जर पूर्ण टाकी ही n तासात भरत असेल तर एका तासात 1/n एवढा पार्ट टाकीचा भरतोय. Example, a cistern is filled by first tap in 8 hours and by second tap in 12 hours. If first tap runs for 2 hours, then find the time required to fill remaining part of the cistern by second tap. By first tap, solution. By first tap, the cistern is filled in 8 hours. Therefore, in 1 hour, 1 by 8 part of the cistern will be filled. In 1 hour, 1 by 8 part of the cistern will be filled. So, in 2 hours, 1 by 8 multiplied by 2. That is 1 by 4 part of the cistern will be filled. Now, how much part remain? Remaining part of the cistern after 2 hours is equal to 1 minus 1 by 4, which is 3 by 4. Therefore, 3 by 4 part is remain after 2 hours. Now, second tap fills the cistern in 12 hours. Therefore, 3 by 4 part of the cistern will be filled by the second tap in 3 by 4 multiplied by 12. That is 9 hours. Therefore, answer is 9 hours. We shall see some tricks for solving problems based on pipe and cistern. Our first tip is, if the tank or cistern is filled by tap in X hours and by second tap in Y hours, then time required to fill the tank or cistern by both the tap is T equal to X multiplied by Y divided by X plus Y. This is the tip. If the tank is filled by tap in X hours and by second tap in Y hours, then time required to fill the tank by both the taps is T equal to X multiplied by Y divided by X plus Y. Example, a tank is filled by first tap in 10 hours and by second tap in 15 hours. Find the time required to fill the tank if both the taps are on. Here, time required to fill the tank by first tap is equal to X equal to 10 hours. Time required to fill the tank by second tap is Y equal to 15 hours. These are given. And as both the taps are running, time required to fill the tank by both taps is T equal to X multiplied by Y divided by X plus Y, which is 10 multiplied by 15 divided by 10 plus 15, which is 150 by 25. 150 by 25 is 6. Therefore, time required to fill the tank by both the taps is 6 hours. Second trick, if the tank or cistern is filled by one tap in X hours and it will empty by the second tap in Y hours, then the time required to fill or empty the tank is T equal to X multiplied by Y divided by X minus Y. When the second tap is emptying the tank, then formula becomes X into Y divided by X minus Y. Note that the filling or emptying the tank depends on the time needed to fill or empty the tank. We shall see this by example. A cistern is filled by a tap in 16 hours and completely filled cistern empty by second tap in 24 hours. Find the time required to empty the cistern if both the taps are running. Time needed to fill the cistern by first tap X is 36 hours. Time needed to empty the cistern by second tap Y is 24 hours. And therefore time needed to empty the cistern by both the taps is X multiplied by Y divided by X minus Y, which is 36 multiplied by 24 divided by 36 minus 24. That is 36 multiplied by 24 divided by 12, which is nothing but 36 multiplied by 2 is equal to 72 hours. Hence, time required to empty the cistern is 72 hours. Next trick. A tank has 3 taps. A tank has 3 taps. First tap fills the tank in X hours. It fills in Y hours by second tap, and it becomes empty in Z hours by third tap. The 3 taps are in such a way that the tank will be filled in X hours by first tap, will be filled by second tap in Y hours, and will become empty by third tap in Z hours. Then, time required to fill or empty the tank if all the 3 taps are running is T equal to X multiplied by Y multiplied by Z divided by X plus Y into Z minus X multiplied by Y. If sign is positive, then tank fills, and if sign is negative, then tank becomes empty. This is a note for such problems. Example, a tank has 3 taps. First tap fills the tank in 6 hours. It fills in 8 hours by second tap and becomes empty in 3 hours by third tap. Find the time required to fill or empty the tank. Time needed to fill the tank by first tap is X equal to 6 hours. Time needed to fill the tank by second tap equal to Y equal to 8 hours. Time needed to empty the tank by third tap equal to Z equal to 3 hours. And therefore, time required to fill or empty the tank by all the 3 taps is T equal to X multiplied by Y multiplied by Z divided by X plus Y multiplied by Z minus X multiplied by Y, which is 6 multiplied by 8 multiplied by 3 divided by 6 plus 8 multiplied by 3 minus 6 multiplied by 8, which is 6 into 8 into 3 divided by 42 minus 48. That is 6 multiplied by 8 multiplied by 3 divided by minus 6, which is minus 24. So the tank will be empty in 24 hours. As sign is negative, tank becomes empty. Example, a tank has 3 taps. First tap fills the tank in 20 hours. It fills in 40 hours by second tap, and it becomes empty in 30 hours by third tap. Find the time required to fill or empty the tank. Here also, time needed to fill the tank by first tap X equal to 20. Time needed to fill the tank by second tap Y equal to 40 hours. Time needed to empty the tank by third tap Z equal to 30 hours. Therefore, time required to fill or empty the tank by all the 3 taps is T equal to X into Y into Z divided by X plus Y into Z minus X into Y equal to 20 multiplied by 40 multiplied by 30 divided by 20 plus 40 multiplied by 30 minus 20 into 40, which is 20 multiplied by 40 multiplied by 30 divided by 1800 minus 800, which is 20 into 40 into 30 divided by 1000, which is nothing but 2 multiplied by 4 multiplied by 3 is equal to 24. As sign is a plus, tank fills. So the tank will fill in 24 hours. Trick. Let the tank has 3 taps. Tank will fill by first tap in X hours, by second tap in Y hours, and by third tap in Z hours. Then tank will fill by all the 3 taps running together is T equal to X into Y into Z divided by X into Y plus Y into Z plus X into Z. This is the formula. T equal to X, Y, Z divided by X into Y plus Y into Z plus X into Z. Example, the tank will be filled by first tap in 10 hours, by second tap in 12 hours, by third tap in 15 hours. Find the time required to fill the tank if all the three taps are running. Time needed to fill the tank by first tap is equal to x equal to 10 hours. Time needed to fill the tank by second tap is y equal to 12 hours. Time needed to fill the tank by third tap z equal to 15 hours. And therefore, time required to fill the tank by all the three taps is T equal to x into y into z divided by xy plus yz plus xz. Therefore, time required to fill the tank by all the three taps is T equal to xyz divided by xy plus yz plus xz is equal to 10 into 12 into 15 divided by 10 into 12 plus 12 into 15 plus 10 into 15, which is 1800 divided by 120 plus 180 plus 150, which is 1800 by 450, which is 4 hours. Therefore, tank will be filled in 4 hours if all the three taps are running. Example: a tank will be filled by first tap in 15 hours, by second tap in 8 hours, and by third tap in 10 hours. Find the time required to fill the tank if all the three taps are running. Solution: time needed to fill the tank by first tap x equal to 15 hours. Time required to fill the Therefore, time required to fill the tank by all the three taps is T equal to x, y, z divided by xy plus yz plus xz equal to 15 into 8 into 10 divided by 15 into 8 plus 8 into 10 plus 10 into 15, which is 1200 divided by 120 plus 80 plus 150 equal to 1200 divided by 350 equal to 120 by 35. 10 get cancelled from numerator and denominator. And if you divide by 5, we'll get 24 by 7, which is 3 hours and 3 by 7 hours. 3 whole and 3 by 7 hours, which is nothing but 3 hours and 3 by 7 into 60 equal to 180 by 7 minutes. 3 hours and 180 by 7 minutes. Example: 8 pipes of same diameter fills the tank in 10 hours. If only 5 pipes are running, find the time to fill the tank. Suppose the tank fills by 5 pipes in x hours. We shall assume this. Then formula is number of pipes in first case multiplied by time required in first case equal to number of pipes in second case multiplied by time required in second case. That is N1 into T1 equal to N2 into T2. This is the formula. Here N1 equal to 8, T1 equal to 10, N2 equal to 5 and T2 is X. We have assumed that time for second case. That is 8 into 10 equal to 5 into X. That is X equal to 8 into 10 by 5 is equal to 8 into 2 equal to 16. Therefore, time required to fill the tank in second case is 16 hours. Example: 9 taps fill the tank in 4 hours. Find the time required to fill the tank by 12 taps. Suppose tank fills by 12 taps in x hours. Formula is N1 into T1 equal to N2 into T2. N1 equal to 9, T1 equal to 4, N2 equal to 12, T2 equal to x. Therefore, according to formula, 9 into 4 equal to 12 into x. X equal to 9 into 4 by 12, which is 36 by 12. It is nothing but 3. Therefore, time required to fill the tank is 3 hours. Next example. One tap fills the tank in 15 hours, but due to leakage, tank fills in 20 hours. Find the tank when the tank will be empty if it is completely filled. Solution: tank fills in 15 hours, so in 1 hour 1 by 15 part will be filled. But due to leakage, the tank fills in 20 hours, so in hour 1 by 20th part will be filled. Therefore, the waste of water in 1 hour is 1 by 15 minus 1 by 20. If we take LCM of the denominator, it is 60, and therefore 1 by 15 minus 1 by 20 can be expressed as 4 by 60 minus 3 by 60. Therefore, 1 by 60th part of the tank is the waste of water in 1 hour. Hence, tank will be empty in 60 hours, reciprocal of that. Next example. One tap fills the tank in 10 hours, but due to leakage, tank fills in 14 hours. Find the time when the tank will be empty if it is completely filled. Tank fills in solution. Tank fills in 10 hours, so in 1 hour, 1 by 10 part of the tank will be filled. But due to leakage, tank fills in 14 hours. So in 1 hour, 1 by 14 part will be filled. Hence, waste of water in 1 hour is 1 by 10 minus 1 by 14. LCM of 14 and 10 is 140. Therefore, 14 divided by 140 minus 10 by 140 equal to 4 by 140, which is 1 by 35th part of the tank will be filled in 1 hour, and hence tank will be filled in 35 hours. Next example, a pipe can fill the cistern in 8 hours, but due to leakage, it is filled in 9 hours. Find the time when the tank will be empty if it is completely filled. Similar problem. Cistern will fill in 8 hours, so in 1 hour, 1 by 8th part will be filled. So in 1 hour, 1 by 8 part will be filled. But due to leakage, tank fills in 8 hours. So in 1 hour, 1 by 9 part will be filled. Therefore, waste of water is 1 by 8 minus 1 by 9, which is 9 by 72 minus 8 by 72 equal to 1 by 72 to part will be filled, and hence tank will be empty in 72 hours. Last example, the cistern can be filled by two supply pipes P and Q in 20 minutes and X minutes respectively. If P is working with 2/3 of the capacity and pipe Q is working with half of its efficiency, the cistern gate fills in 20 minutes. Find X. This is a different problem. In this C, the cistern can be filled by two supply pipes P and Q in 20 minutes and X minutes respectively. If pipe P is working with 2/3 of its capacity and Q is working with half of its capacity, the cistern gets filled in 20 minutes. We have to find X. Capacity of the cistern is 20 multiplied by X, because by first pipe it fills in 20 minutes, and in section it fills in X minute. Therefore, capacity of cistern is 20X. Efficiency of pipe P is 20X by 20, that is X. Efficiency of pipe P is X. Efficiency of pipe Q is 20X by X, that is 20. Then P is working 2/3 of its efficiency. Therefore, new efficiency of P is 2 by 3X. Q is working with half efficiency. Therefore, new efficiency of Q is 1 by 2 into 20, that is 10. As cistern gets filled in 20 minutes, 2/3 X plus 10, this is the efficiency of both the pipe together, multiplied by 20 equal to 20X. If we solve this, 40X by 3 plus 200 equal to 20X. 20X minus 40 by 3X equal to 200. 60 by 3X minus 40 by 3X equal to 200. 20 by 3X equal to 200. X equal to 200 multiplied by 3 by 20. That is 30 minutes. Therefore, value of X is 30 minutes. Thank you. See you in next video.